Hi, welcome back. For this last video, we're going to see how we've modified the script to handle something a little bit more outside the box. As you can see, this is not a simple 2-bone system. This is actually a 3-bone system. And I'm not going to go through how to build this rig in too much detail. One, that kind of goes beyond the scope of the lesson here, and two, one of my partners at Double Helix has already covered this in the second half of our masterclass from 3 December. So if you want to just go up to Autodesk's website, you can see how he built a rig very similar to this. I'll go over the basics real quick, and of course the complex example.ma should be on the DVD, so feel free to reverse engineer it. But I will just very briefly explain how this works so we can explain what it is we're actually having to solve for. To begin with, let me turn off nothing but the joints. We actually have 3 bones, and RP solvers really work well with 2 bones, and SEs work well with 1 bone. The only IK handle that even comes close to solving this single-handedly would be the spring IK solver, which you would actually have to go Windows, Settings and Preferences, plug-in, and it ships with Maya. And it's IK Spring Solver right here, if you can load that up. But that really doesn't give us the kind of control that my animators demand of our rigs, so we don't use that. And I've actually had problems getting it to work reliably as well. So what we do is we actually have 2 systems. We have an IK system that going from here to here, and then from here down to the bottom. So how do we get that all to work as a unit? Because the last thing you want to do is pull a control and have the top half move, but the bottom half is going at an angle. As you can see here, this is I built this proxy to illustrate we want it to be very, very rigid. This is like a robot rig, and we actually started building these rigs because I had to deal with this. My first master class, I talk about this as well, because we had a creature that had robot legs. It was the final boss monster in Silent Hill. We had similar robots with spider legs like this on G.I. Joe, and then again on the big boss monster or boss character halfway through Front Mission. So we've kind of polished this rig to a sheen. We've seen it about 3 or 4 times. But it's mechanical. We want it to move as a unit, and we have it rigged up so if we move it side to side, it's going to stay at a plane. Notice how everything's rotating from up here, and we're getting bend angles here, which, as you can see, these are actually locked. They can't bend in any other direction. And then we can further manipulate it using the pole vector control, and everything stays nice and aligned, which is something that was robotic you would want to or mechanical you'd want it to. But then we have the additional feature of being able to pivot it from the foot up. And that's the part that's going to cause us some problems with our IK-FK switching. So how do we go from IK to FK? Well, pretty much the same way. We record the FK rotations. We turn the IK blend off on our controller, and then we set these rotations back. That part's pretty simple. Going from FK to IK is going to be more complicated. Well, we know where the IK controller is going to need to go. First of all, we know that this is an IK control. It's not a simple IK handle, because this one's actually running 2 IK controllers, IK handles at once. There's our controller, there's the 2 IK handles. So, as you can see here, this is our IK blend from the controller being plugged into each one of the handles. So that's fine. Our script is already smart enough to find a controller as opposed to an IK handle. It'll find either, but in this case it's going to know to find the IK control. And that is actually plugged into an FK marker. See, we've got the IK switch control there. In the previous examples, we plugged this directly into a joint. In this case, we're plugging it into a marker, but it works the same way. The script doesn't care if it's a joint or a marker. All it cares about is that this connection is made, and the transforms of this match the transforms of this at 0 pose. And then that is simply parented to our FK system. Same with our pole vector control. That too is mapped, or not mapped, but is connected to a pole vector marker. And that pole vector marker is a child of the top joint of our FK system, just like it was in the two-bone system. So those two parts are the same. We've already seen that, we've done that, we should know how that works by now. The part that we don't know is what to do about this ankle joint. We don't know what this is. So think about it. If I switch to FK now, and then switch to IK, this is not going to work. Actually, it's going to work because I've already added the code to make it work, but without those additions to the code, just by what you've seen so far, this should not work because we already know that the code will zero out all of our custom attributes. And even if it didn't, let's just do the IK switch there. You know, if we had done something like this, you know, would the IK system know what to do? Well, in our case, it will, because we have created added to the system the ability to figure that out. Now, how did that work? Notice that our ankle value had to change. Let's undo a couple things. See there, it's 22. Yep. Now it's 24 point something or another. So this ankle driver was able to update itself so it had the correct value to maintain this pose when it switched to IK. That's the next trick, and that's the last trick I'm going to show you on this IK to FK switching.